In the name of God, the most gracious, the most merciful. Today, God willing, we will discuss the subject of blast-resistant buildings. As well, we will discuss how to calculate the loads on it, whether statically or dynamically.
Now, let us consider that I have a building shall be designed to sustain the blast load. So I have to go to a specific strategy for design. We call it a blast design strategy. What does this strategy consist of? It consists of three main things. The first thing is to have a meeting with my client, and we understand all potential cases and levels of the hazards and risks, such as the building occupancy, whether it is the VIP palace, military building, sensitive factory, data center, etc. Whatever the use of it is, I define the criteria of this building. I have to specify the level of protection that my client wants, whether the target is to have partial destruction or non-destruction building at all. All the things of the design criteria are agreed upon with the client. The shipment that will explode in front of it, we agree on it. For example, it will be at this distance. It will put a barrier at a certain distance. And the possibility of the farthest car will be where? Whether there may be a blast from above, whether there is a blast on the left or right, because there are three cases of explosion. Either it is, as we said, free air burst, or air burst or surface blast. So these three conditions are determined initially, or I will design with all three conditions, because we can design a building that is damaged to a certain limit, and then it is repaired. And we agree on the load that I will design on it, and everything, and the possibility of putting barriers where, and so on. So the design criteria is the first thing I specify with the client, with the core, according to the scenarios that I agree on. And the contract is signed on it. So this is my design. Everything has its cost. So we know from day one what we will do. Then we agree on the scenario that we will work on. We know the scenario that it is. For example, a surface. So should expect that the blasted car may come to stand at a certain distance, and how far it is from the planned barriers locations, and so on, until I know the nearest distance, where it comes from. And it also gives me the dimensions of the building, and how it looks, and its face, and everything is finished. Consequently, I will be able to start to specify the design load diagram of it, based on these considerations. We will say it a little later, after we see the third step. So after we specify these parameters, as well as all potential scenarios, we will be able to get the load diagram that represents this condition. And hence we will be able to deduce the corresponding curve that represents the dynamic response of it, which we can make it static. The third step, if I finish these steps and got the load as well as the design criteria, I will be able to design the structure itself, that it is designed with general considerations, because it is also a design for blast. The structure itself as a structure analysis, the structure design itself as a design for specific considerations, not design considerations for wind loads nor seismic or such ordinary loads. There are other considerations that we will see in detail during this and next lectures. How is the scenario that I followed with it? For example, I know that it is a surface blast, that is a car that explodes on its own. I tell it a maximum, so I know the weight of my explosive shipment, or it is specified. It can be that this car is removed and its material, and I know its type, the type of detonation that I will design on it. That is, this country is known for the possibility of an explosion in it, especially if I design a building in a military area. I am already in a military area. I know that this area stores walking things, God forbid, things that explode while walking. So I know the weight of the shipment, the car's weight, how much it removes, and the type of detonation itself, the material that explodes. What type is it? Because then we will enter the conditions, as we will see, and also the distance. I know the barriers here. I put the barriers together, and so on. So of course it will not be able to enter before that. So I know the distance, the weight, and the type of shipment, its weight and its type, and the distance that separates it from my building after that. Based on this step, I start determining the wave parameters that we will see. the wave parameters that we will see in detail now. After we see the third step, I finished the wave parameters and I took them all out. After that, I enter my famous curve, which is the peak pressure, the reflected pressure, the positive zone, the negative zone, and I draw my diagram. And now I am ready to enter a time history for the eta chaos or any program to solve it as a dynamic analysis. Or I idealize it and turn it into a static curve. Simply put, the steps will never come out like this. I will not repeat it again. All the steps in front of you now are these 3 steps. They are in yellow, as you can see them like this. And after that, the steps in red are the detailed steps for the important step, which is how to determine the load, how to determine the parameters. To determine the parameters, I will determine some things like this. 4.5 parameters. I will determine them. The peak incident and reflected pressure in detail like this. And it is the wave of the blast entering the building. That does something called peak incident. When it moves like this, it is called incident. Once it collides with the facade of the building and is reflected, it is called reflected pressure. So the wave of the blast as it moves in the air has a normal pressure, that is, the pressure is of course strong, but it is not compared to the reflected pressure. The reflected pressure, once it collides, it is, for example, from 2 times to 12, 20 times. It is an amazing thing. So the reflected pressure is what I design on the main face, and the peak incident pressure is designed on the other faces. After that, the incident and reflected impulses. Once it is not just a pressure, there is a pressure and an impulse as well. It is a curve in the building as a result of this pressure. It is called an impulse. We will calculate it and get its parameters. After that, we get the wave front speed and the wavelength. I also need them. I need all these things to get the diagram. Pay attention to all these parameters to draw the diagram that we want to draw. There are 3 things so far: pressures, reflected and incident, and also reflected impulses, and also the wavelength and wave speed. After that, the arrival time. How long did it take? I know that the car stopped here, and then the wave did not reach the building. It took time. This time is measured in milliseconds. This is also important because the curve will intersect with the x-axis. This is very important when I draw my diagram. After that, the curve has an exponential decay until it reaches the point 0, which is the point where the curve turns from the positive phase to the negative phase. At this turn, it is called the duration of the positive phase. So guys, if I got all these parameters through my conditions, I can draw the diagram that we will use later and make it an idealization for the static, or take it as it is and put it as a time history in the dynamic. After I get all these things, I will start to analyze my structure. How is my structure analyzed? It is analyzed either by a dynamic non-linear finite element, and then something called dynamic properties is inserted into the structure, not the static properties that we know. There is something called dynamic properties, which depends on the high strain of the structure. The structure gets a strain above the description, so the strain that is obtained should not be like the strain that we know. And if it is low, it is static. No, there is a very fast acting strain as a result of the explosion that collides with the building. So there is another type of parameters called dynamic properties, dynamic concrete properties, or dynamic steel properties. We will see it in detail later. So this is the main difference between when you come to do an analysis of the seismic and an analysis of the blast, or an analysis of the wind, or the analysis that we all know. It is static, and thus you interfere with the stress-strain curve that you know. But here, in the case of the blast, no, the subject enters another link, which is non-linear finite element analysis, which is based on the dynamic properties of concrete. This is the first method, or it is better with something called a simplified member. By member analysis technique, which we will also see, God willing, but of course in advance. In principle, this part will take several lectures because of the 3 steps written in red in front of you. They will need several lectures to illustrate. After we finish all of this and get the loads, we will go to the next step, which is how to do the analysis itself. I hope that this strategy is clear for all of you, because if we know the blast design strategy, we will be able to deal with the blast resistant building analysis and design very easily.
Thank you for participating in this session. Should you have any questions or feedback, please feel free to reach out to me via my Facebook page, LinkedIn profile, or by leaving a comment below this video on my YouTube channel. Best regards.